So we're interested in finding the following limit. The limit as x approaches infinity of 2 over x minus 3. Now we can use limit laws to help us find this limit. Using our limit laws, this would be the limit as x approaches infinity of 2 over x minus the limit as x approaches infinity of 3. Now we've already established that the limit as x approaches infinity of any constant over x to the r power, where r is a rational number, is equal to 0. So we can apply this property to this limit we have. So the limit for 2 over x applying this property is 0. Minus the limit as x approaches infinity of 3, which is 3. So the limit of this function is negative 3, meaning this function as x approaches infinity should approach negative 3. And as we can see here in the graph of this function, that this dotted line at x equals negative 3, our function as x gets larger and larger, approaches infinity, is decreasing and getting closer and closer and closer to negative 3. In this case, we have a limit as x approaches negative infinity of the quantity 4x to the 4th plus 3x squared plus 5 over 3x to the 4th minus x minus 1. So this is a rational function. It is a quotient of polynomials. And so what we want to do is, in instances like this, take advantage of the property that we know that the limit as x approaches negative infinity of c over x to the r power, where r is a rational number, is equal to 0. Now, the function in its current form does not lend itself well to applying this property. So what we want to do is rewrite this function so that we can apply this property. So what I'm going to do is I'm going to look at my denominator, and I'm going to look at the highest degree in my denominator, which is x to the 4th. I'm going to multiply both the numerator and the denominator by 1 over that power, x to that power. So in this case, multiply both numerator and denominator by 1 over x to the 4th. Now, keep in mind that I'm just creating an equivalent form of this function, because as long as x does not equal 0, this simplifies to 1. So let's go ahead and rewrite our limit. So keep in mind, this is basically asking us a question: how does this function behave as x heads towards negative infinity? So using the distributive property in the numerator, I'm going to get 1 over x to the 4th times 4x to the 4th. So that's giving me 4x to the 4th over x to the 4th. Plus, then multiplying 1 over x to the 4th with 3x squared over x to the 4th. Plus, and then multiplying 1 over x to the 4th by 5. So 5 over x to the 4th. That's our numerator. And now we're going to do similar in the denominator. So 1 over x to the 4th times 3x to the 4th minus x times x to the 1 over x to the 4th. My apologies. minus, and then finally times the minus 1, so 1 over x to the 4th. Now, let's go ahead and simplify some of these. So limit x approaches negative infinity. Let's start with 4x to the 4th over x to the 4th. The x to the 4ths will simplify and leave me with a 4. Moving on, plus 3x squared over x to the 4th. That's going to leave me with a 3 over x squared. Plus, and my final term in my numerator, 5 over x to the 4th, cannot be simplified. Divided by, now looking at our denominator, my first term, 3x to the 4th over x to the 4th. The x to the 4ths can divide out, and I'm left with 3. Minus x over x to the 4th can simplify. That becomes 1 over x cubed, and then minus 1 over x to the 4th, which can't be simplified. Now, as we take a limit as x approaches negative infinity, this property of ours becomes important. As x approaches negative infinity, this 4 is not going to change. It will remain as a 4 plus, now taking our limit, this 3 over x squared, applying our property, we have c is 3 and our exponent on our x is 2. So that's going to head to 0. So this is plus 0. I can apply that property again here with the 5 over x to the 4th. That's going to head to 0. So I get a plus 0 here. Then looking at my denominator, limit as x approaches negative infinity of 3 does not change the 3. Minus, and then I have 1 over x cubed. I can apply my property again. That goes to 0, so minus 0. Minus, and then I have my 1 over x to the 4th. I can apply the property again, so that heads to 0 as well. So the limit here of my function as x approaches negative infinity is equal to 4/3. Meaning that as x heads to infinity, the values of my original function approach 4/3. And we can see that behavior here in our graph of the function. As x heads towards negative infinity, you can see this horizontal line this is at 4/3, and the function is approaching 4/3 and getting closer and closer to 4/3. Now let's look at the limit as x approaches infinity of the quantity 4x squared minus 3x over x cubed plus 8. So again, this is not in a form that's necessarily friendly for applying what we know about the limit as x approaches infinity of c over x to the r, when r is a rational number and c is any constant. We know that that's equal to 0. So we're going to apply this same strategy we did in the previous example. We're going to multiply our function by 1 over x to the degree of the polynomial in the denominator, highest degree, so 1 over x cubed and 1 over x cubed. And keep in mind that all we are doing is creating an equivalent form of the function, provided x is not equal to 0, which as x heads to infinity, it won't. That's simply a 1. Simplifies to 1. So this is the limit as x approaches infinity. Now we're going to use the distributive property to multiply this out. So we'll get 4x squared over x cubed as our first term in the numerator, minus, and we'll have 3x over x cubed as our second term in the numerator. Now doing likewise in the denominator, we'll have x cubed over x cubed minus 8 over x cubed. Now when we do this, now we want to simplify what we've created here. So we'll have the limit as x approaches infinity. My 4x squared over x cubed, that simplifies to 4 over x, minus, we've got 3x over x cubed, that will simplify to 3 over x squared, all over, now my x cubed over x cubed, that's going to simplify to 1, and then we have minus 8 over x cubed. Now, we've rewritten the terms in this function in a form that allows us to apply this knowledge we have about the behavior of c over x to the r. So now we can say that we have the limit, or actually we can take the limit. We can say that we have, as x approaches infinity, my 4 over x, based on that property, will head to 0. So we'll have 0 minus 3 over x squared. Again, I can use that property. So that heads to 0 as well. Notice that in my denominator I have a 1. So as x heads to infinity, that doesn't change the value of 1. Minus, and then my second term in my denominator, 8 over x cubed, I can apply that property and that heads to 0. So I end up with 0 over 1, which is 0. So that means that as x heads to infinity, the function values produced by our original function head to 0. And we can see that occurring in the graph of this function. As we head out towards positive infinity, notice that these function values are decreasing closer and closer to the x-axis, or closer and closer to 0. I hope this helps.